All right, let's get started for today. So, today we're going to be talking about other kinds of specialized functions. So, it's going to be pretty simpler stuff today, just some general functions, nothing too crazy. Um, so, if we take a look at our review question for the day, when you are setting up a one variable data table and your substitution values are arranged horizontally in a row, where exactly must you enter the first formula reference? So last time when we were working on doing one variable data tables, we were doing a vertical one, right? And because of that, when we created a vertical chart. Let me show what that looked like from last time. If I could pop that up. Okay. So we had to put that essentially in the top right-hand corner. So from the original reference, one up and one to the right. However, it's a little bit different when we're dealing with it horizontally instead. Instead of going to the right, we're going to put this towards the left instead. So this is going to end up being on the row below and one column to the left of the first substitution value, right? So we could see over here that this value instead should be over here. The formula itself got unlinked when I transposed it, but I could just simply link that again, right? Just by having that equal instead of n10, right? We could just make that equal to our other formula, let's say B19, right? So this was our reference that brings us here, which brings us here. And this is the reference to our formula. So if we're doing things vertically, we go up one to the right. We're doing things horizontally, we go down one to the left. So that is how we do our one variable data table. Two variables, it's always going to be in this top left-hand corner because we have data not just to the vertical part, but also to the horizontal part. So for a two variable, we have it in this corner. For one variable, we have it in the other corner. So that's just kind of a little review for what we were doing yesterday. Any questions on that before we go on, or any questions in general for things? I just realized this is not correct. I didn't put the right things in here. I just want to clarify, we're doing chapter 7 today. Accidentally copied chapter 8. I did not have enough coffee this morning. And forgot to also change the deadlines. I kind of went on autopilot and had the old deadlines. Our spreadsheet has the exact deadlines and what is going to be on each day. So today's assignments is just homework 1 through 3, project 2. All of this week's assignments, right? So all of the red assignments are the ones that are graded. So homework 1 through 4, 1 through 4, 1 through 3 is going to be due on Monday night. This allows you to have the chance on Monday's lab to not only work on today's assignment, but also ask any questions that you have. Also gives us time to respond to any emails in case there's any issues with the grading, because I know it's been a little bit hard with Pearson. We had posted instructions on how to solve that issue that was going on. So if you take a look at the recent announcements, there was also the fix for the issue on solving this specific project for chapter 5 on a Mac instead. And again, if the auto grader is not doing what it's supposed to do, don't worry, just email it to us. Make sure you CC both of us in there, and we will absolutely fix it. So it's not a problem at all if you submit it via email instead. Just you got to let us know beforehand. Otherwise, we won't know if you submitted it or not. So just to kind of clarify that. Okay. Any questions about projects, homework, things that we're doing, anything in general? Okay, good to go. Alrighty. So Gonna just try to go through it a little quicker today since it's gonna be nothing too crazy. Yesterday's was a little bit on the harder side. Today's a little bit of an easier topic, I would say. And this will be the second to last topic that will be on the next midterm as well. As a reminder, it'll be for 5, 6, 7, and 8. But given that 8 was literally going to be taught the day before the exam, it will have a much higher uh, question count for chapters 5, 6, and 7. So when we go over chapter 8, the types of questions that will be covered on exam 2 will be much simpler questions. Of course, our final will be cumulative, so expect everything. Okay, with that being said, let's get started for the day. Okay, so again, what is Excel if we don't have functions? So we're going to be continuing our journey into a variety of different functions that let us kind of manipulate different dates, different times, other kinds of financial functions as well. So we're actually going to be talking a little bit more about that infamous PMT function that was kind of given in a couple of the previous labs, but never fully explained. So you're going to finally get your questions answered on that. And just kind of a variety of functions that you're going to be able to add to your toolbox. So if there's a question that's saying, hey, how do I calculate the number of days between two given dates? Now you're going to have a function that can do that. Or how do I find a principal amount in an interest formula? You're going to have a function to do that. So the key here is really being able to kind of match up these kinds of functions, knowing what the function is, what it does, and when you would use it, right? Um, Knowing its structure is good too, but as you've seen on the exams, we're going to keep it to be more like just kind of matching, understanding the formula itself, not necessarily just memorizing its structure. Because again, you can Google up any formula, you have your notes. It's more important that you actually understand the purpose of the formula and how it works. Okay. So if anyone's in accounting, economics, etc., a lot of these guys will probably look very familiar for you, and you're probably going to be a pro at it. So first things first, we're going to start off with our date and time functions. So we had gone over briefly that there is a function called the today function, right? If I open up my Excel over here, let me not have 100 tabs open so that I can actually be organized for once, right? I could use the function equals today. And oops, there we go. Don't forget the parentheses. So this will just give me the actual date of today, right? So you can just ask Excel, hey, what is today's date? Just using the today function. Now, we also know that every date is essentially a number, right? It's an encoded number. So if I actually change this into the general format, right? Getting rid of the date format entirely, I get this gibberish number, right? We concluded that this number is not actually gibberish, right? It's actually a set number of days counting, right? So it allows us to do arithmetic between days. If I wanted to calculate how many days old I am, let's say, I could enter my birthday here, right? And I could enter today's date and I could subtract the two together, right? So if I wanted to calculate how many days it's been since whatever, right? I could just calculate it that way. So actually, let's calculate how many days it's been since our first day of class, right? So it's 6/1/26 was when we started, right? I'll put this back into a date format just to make it a little bit easier to see, right? And I can just calculate this minus this, right? 10 days. Okay, you didn't need a formula to calculate that, but if you have things that are separated by many years, let's say, then it's good to have this type of formula involved, right? Because we're not used to thinking of dates in terms of numbers. But because these guys are encoded with that, I can do all these operations. And furthermore, there's a lot of other functions that allow us to take this one step further, right? For instance, I was just using the plain date. Now, I could have made this into a long date or a short date, right? That was a part here that I could change it to, right? Long date versus short date. So short date is 6/11/26. Long date actually has the day of the week, the month spelled out, the entire year, etc., right? But both are just a way of encoding that same thing. What if I only want to have the day, the month, or the year, right? I could use that using the day function, the month function, or the year function. So I could extract all of these different components from these values. And when we ask for serial number, right, that's only just asking for the encoded value that we get from here, right? This value right here. So I can wrap this function and I can say day of today, right? It's 11, right? Today's June 11th. I can wrap multiple functions together because what does the today function return? Just a serial number. And that's all that this day function is asking for. So I could wrap it into the today function and say day of today. I get 11. If I do month of today, it's June, it's 6. If I get the year of today, etc., right? As long as I have that date or its serial number, right? Because again, it's the same information, just formatted differently. I can extract anything that I want. So I don't know, maybe I have a spreadsheet that is calculating, that has a column for the day, the month, and the year, let's say, right? I want to separate them for some reason. Maybe I want to group by the month, right? I could just use the today function or hard code a specific day or any data that I have, and I could extract these different pieces from it. I could even do math if I wanted to calculate how many months it's been in between of two dates or how many days it's been. So a lot of really cool things that you can do with this. Okay, and aside from hard coding it, if I wanted to essentially find these in our formula bar, right, we know everything's grouped super nicely up here. And I could just say equal day if I want, just like how I did in my example, but I could also go to the date and time key up here, right? Formulas, date and time. This has a lot more formulas aside from just day, year, month. There's a lot of other things too. We're going to be going through a couple of these ourselves, but this is definitely way more than you'll ever need. But it allows you to do so much math and arithmetic that you never have to guess how many days has it been between something, right? Okay. So aside from that, right? Now if you're in industry, you're probably going to be working like a 9 to 5 job, Monday through Friday, etc., right? You know how that everyone says, oh, it's going to take X amount of business days to get a package or to do something or to respond to your email, right? Business days, Monday through Friday. We don't like counting Saturday and Sunday. Well, thankfully, there's a function that allows us to do that by default. That's going to be the network days function. So what this is essentially saying is I take 2 days, right? 2 dates, and I'm going to calculate how many actual working days or network days there are within this. So we plug in not just the date itself, right? But we're finding a range of dates. So if I want to find just the plain old days, right? I could just use the days formula. I could say the end date and the start date. Okay. And essentially, it's going to work identical to the way that I used the formula here. Let me get rid of this because, as you can see, by changing what this value is, by putting it inside another function, it messed up what this value is, right? We can only subtract one entire date from one entire date, a month from a month, a day from a day. Otherwise, it's going to get really screwed up. So if I go back to this, right, I know that I could just subtract one of the dates from the other dates, right? That's totally fine. I can do something like that. But if I wanted to, I could also use the days function to do that too. So I'm just going to say end date comma, start date, right? 10. Same thing, right? That's literally what that function is doing under the hood. It's just subtracting one date from another because, again, these guys have serial values. All right, but in between these days are a lot of weekends. We don't want to count that. So how about I use my network days instead, right? So what I'm going to do is I'm going to now plug in the start date, 6/1, comma, the end date. Now, there's an optional parameter here, right? You could see optional parameters have those brackets around them called holidays. And this is going to allow us to pick and choose exactly which days we don't want to include. Because maybe you're working on a weird work schedule that has off on Wednesdays instead of the weekend or something, right? Those holiday days allow you to change that. But for the time being, let's just stick with the default, right? And now it has 9 days, right? That shows that there are 9 network days that are between the 1st of June and the 11th of June. So if we take a look, right, we can essentially calculate how many days excluding weekends, or if we want, we can actually hard code it a little bit more, right? For instance, let's say I want to have if I don't want to include Saturday and Sunday, right? So instead of using network days, I'm going to use network days.intl for international. This is going to allow me to switch things up a little bit, right? So I'm going to change this to network days intl. Okay. If I don't include a parameter here, right? This is going to omit just my weekends, Saturday and Sunday, right? Makes sense. But if I end up including a different argument here, right? It's going to end up choosing any of these options, right? So let's say I think that Monday and Tuesday are a weekend, right? Well, I could choose 3 as my argument in that tab to say I'm just not going to include those days instead. Now it goes down to 7 days because we've now chopped off a Monday, or wait, what did I say it was? A Monday and a Tuesday, right? So if I don't want to have a Monday and a Tuesday, those are the days I get off, right? I can include 3 in there and it immediately chops off those 2 days, right? In our previous example, Saturday, Sunday, there was only one weekend day in between of that. So therefore, it only chopped off one day. But you can play around with it and it allows you to really customize things. Maybe you only get off on Sunday. Maybe you only get off on Monday, Friday, Saturday, Thursday, Friday, etc. This allows you to truly calculate those business days. So if you want to just use the default, right? You're going to use network days. If you want to hard code it a little bit more and show, let's say, you can hard code one of these arguments to get rid of an entire day automatically. So if I have the start date here and the end date here, using just days, right? Okay, just gets rid of that, right? I plus 1 if I want to include the current day in there, right? If I don't, then it's the 1 day short. If I want to say now the network days, right? So Monday through Friday by default, I can just do that here. If I want to get rid of a specific holiday, I include a third parameter. And if I want to switch what days are counted as network days, then I use the international INTL to switch the third parameter instead of being 1 day only to be a series of days, right? 11 is Sunday only. This is going to say every Sunday is a holiday. The previous one, B3, is saying the only day you get off is on the 6th of September. So, variety of different ways of calculating the days between things. But under the hood, all it's really doing is just subtracting one of these days from another because all these guys are just numbers. right? And if, let's say, I put a day in the middle here, it's just subtracting an extra day. It's like saying take B1, B2, subtract it by B1, and subtract one extra day from it, right? If I want to add that day back in, let's say, right? I want to actually include all of the days, then I can always add it back in if needed. So this is just a really nice way of being able to calculate those amount of days. So now it's easy to see on a like within the same month. But if you're dealing with multiple years, if this was like 2024 and this was 2027, right? It's a lot harder to calculate. So that's where these functions really shine. I could find out how many days until I graduate, let's say. If I wanted to put my date of graduation here, right? And I could calculate how many days there are. Or if I want, have a countdown. Use the today function and count down how many days between your graduation day and today. And that can be your spreadsheet that counts how many days until graduation. So a lot of really cool things for this, and it makes your life a lot easier. Okay. Oh, and they continue, right? So if these are having actual weekends, having 2 days, but if you only want one day, you could use 11, 12, 13, 14, etc. Don't worry about memorizing these as much. Just understand that that third parameter in Network Days International is going to eliminate certain weekends or holiday days. So again, you have your notes with you, just knowing that these guys correspond to this and take off days, you'll be totally fine with that. Okay. So let's go on to handling specific years and weekdays. So aside from dealing with specific days that we're looking in between of, right? Let's say I wanted to find out how far I am in a certain year, let's say, right? Let's say I want to find the essentially percentage of where I am within 2 dates, right? This is where the year frac function shines. So let's say I have these 2 dates. I have April 1st, 2026 and October 1st, 2028, right? This is going to tell me that between these two guys is 2.5 years. So we know that, yeah, okay, going from 2026 to 2028, that's 2 years, right? And we have 5 months on top of that. So this decimal is telling me the amount of years in the first part, the amount of months in the second part. So it's essentially calculating a fraction or technically a decimal value of kind of how much is in between these guys. So if you have things within the same year, right, you're going to be dealing with a decimal less than 1. If you're going to be dealing with things that are larger, like between different years, then you're going to have something greater than 1. And now if you want to get the nearest year, you can use our round function to essentially wrap our year frac function. Because year frac is just going to return some decimal. This is going to sub in 2.5. And I can choose to round, just round to the nearest, round up, or round down, right? Maybe I want to estimate how many years it's going to take me to do a project or something, right? If they want to give me if I want to give my employer a conservative estimate, I want a little extra time. Maybe I want to round up. I want to make sure that they give me the full 3 years to do the project, even though I know it might only take 2.5. But maybe they really need this out soon and you got to hustle. Round down, even though it might take 2.5 years, you have to take that second, you have to take only 2 years instead. So a lot of other ways of essentially getting our percentage of years, making sense of dates, and finding the amount of time that there is between 2 dates. Then there's also the weekday function as well, right? So let's say you want to find out what day of the week a certain day is, right? I give you some arbitrary date, let's say June 15th, and you don't know what day of the week it is, right? I mean, of course, we can look things up, but let's say you're just on Excel and you need just to know it really quick. Don't want to open up your calendar? Use the weekday function, right? And all you're going to do is plug in the date, right? Serial number just corresponds to a date. We know every date corresponds to that serial number. And it's going to actually give us the day of the week in terms of an integer, right? I can choose to format that as a default integer, right? So Sunday being 1, Monday being 2, Tuesday being 3, et cetera, et cetera, et cetera, et cetera. Or if I want, I can have that formatted, right? We know we can format any of these numbers into anything that we need, right? If I have integers by default, right, and I go to the Format tab, aside from formatting it in the ways that we're familiar with, like number, currency, accounting, etc., I could also choose this custom icon and have it specified with DDDD, which gives us a corresponding weekday. So this is an extra way of interpreting this data, right? If you want to find out what day of the week all of these guys are, right? Maybe this makes sense to you after learning Excel, but someone who doesn't know Excel might not understand what these numbers correspond to. So by formatting it to show the actual date itself, right, makes it so much easier to see. This is a Friday, this is a Monday, etc. Right? So for those unknown days, you can do it that way. So let's say I'm going to take the weekday function of this guy over here, right? Oops, I need to put an equal sign. Okay, oops. All right, let me actually do that on a separate tab then. Equal weekday of that guy, right? Okay, 2. Okay, so we know that this is a Monday, right? And it makes sense because June 1st was the first day of our course, which was on a Monday. All right, how about I format this guy, okay? And I'm gonna essentially get him to kind of look in the form of a uh weekday instead, right? So I'm on my format cells tab over here. I just right clicked, I went to format. We know we have all of that. I'm gonna go to custom down here, right? And a lot of this is already predetermined, right? So I'm gonna just find that day one over there and we can use that. Okay, I see that they have day, month, month, month. Right. Okay, let's take a look and see what this would get me. Okay, that's just going to be the day and the month. Um, so again, everything does have that corresponding serial number, and that's how it's able to essentially correlate that. Let me just type in manually. There we go. Okay. So if something is not right there in format cells, right? If it's not in the custom already, I can add things freely, right? This was not there before, right? They had a bunch of other presets, but I can choose however I want. If I have 4 Ds in a row, this is going to get me corresponding my integer to the day of the week. Now, if this integer was not between 1 through 7, right, this would give me an error. The only reason that this successfully works is the weekday formula is going to give me an integer between 1 and 7. Otherwise, right, how am I supposed to know what the 8th day of the week is? It's not going to make sense. So doing that allows me to format that a little bit nicer. So aside from using weekday, formatting, putting it together, I get my day of the week. So easy way of finding out. Okay, June 1st. Yep, that was a Monday. And once you make the one formula, if I had a bunch of days of the week, I'm free to just drag and fill, and I could get all the other days of the week and have something formatted alongside like this. So a lot of really cool ways that you can format things aside from just the generic versions. Okay. So let's say that we have our serial number and we want to kind of specify this specific date, however many months it is in the future or in the past, right? Now, we know we could just find the number of days if we want, right? But that's not going to tell us if that date was in the future or in the past. If I want to show that this is in the future, I want to show that, let's say June 25th is plus how many days in the future. If I want to show that it was June 1st, I want to show it's minus how many days in the future. So this is great for showing, let's say, deadlines. Maybe you have 5 days to do something. You want to show that it shows +5 as the deadline. Or maybe you're 10 days late. You want to show -10. So using the eDate function will allow us to essentially do that. So if I have my start date and my calculated date, right, it's finding if this date, right, is before or after my start date. Well, we know that October comes after April. So this is going to be a positive number. It's showing me that I have exactly 6 months between the start date and the calculated date. What if I go backwards though? Start date is June, calculated date is January. Now I'm going back 5 months. It's telling me that it is a -5 now. So this can immediately tell me, am I ahead? Am I behind? How many months are in between of these guys, right? And is it going ahead or is it behind? So if you have deadlines, easy way of showing that. So there's a variety of these functions which can be found right here in our formulas, right? These are all of those functions there, right? So like days 360, eDate, all of these guys. Couple of notable ones, right? If let's say I have my regular date function, right? We're good with that. I can just have it formatted right from there. I don't have any format on here, so I'm just leaving it like that. But again, maybe I want to get the day of the week. We know how to do that. All kinds of things like that. Let's say I want to turn a date into a value or vice versa. I can use the date value function to convert between the two, right? So instead of just taking B4, right, which is just 531.27, I can convert it into a value itself. So instead of formatting it manually, right, maybe I'm sending this to a spreadsheet to a friend and they didn't format it correctly, right? And I want this shown as a value instead of a date. So using the date value function allows me to hard code that so I ensure that it's always going to be in that format. Now, of course, I'm free to format it afterward as a date, right? I can go back, I could go forth, easy to do. All right. What about if I want to take C1 and C2, right? And I want to find out how many days are in between of these guys, right? Well, in a case like this, right, I could say days 360 and calculate, okay, we have 360 days between those, right? So we can continue on. We have EO month, similar to our E date, right? We can calculate that. Is week number here. These two week number functions are finding the number of weeks it's been since, let's say, whatever our B1 is. So this is counting the 17th week and 18th week, right? Our function here, where it says is not going to be including the week, while week num is. So a lot of these functions are going to be using inclusive or exclusive as different parameters. So if I want to essentially say this week, like the start of the week, right? I know that this is the 17th, this is the 17th starting at the starting point of this week at May 1st. I have finished 17 weeks of the year. This is technically the 18th week of the year. If I want to say that how many weeks have passed, I will use the is_o_week function. But if I want to say what week I am currently on, that's going to be the week num function. So ISO is going to tell me how many weeks have passed. The week num is going to tell me what week I am currently on. So it's a question of, am I including or excluding the current week? That's why it's giving us two different answers that are a single number apart. Okay, and finally, for the workday function, if I take my B1 over here, I calculate 90 workdays in the future. It will output how many workdays there are between these two, right? And we know we get a serial number, but that could be freely converted back and forth between a date and a serial number easily. So again, it's a lot of different functions going on. I would focus on the main ones. These are good to know. It's good to know kind of like the difference between some of them, especially in like the subtle cases. But otherwise, it's more just so you kind of understand that there are a variety of these functions here. You probably will not use some of these as much as, let's say, finding eDate or the weekday function, year frac maybe even, or especially using days and network days. This one is used all the time because maybe you want to find out how many days there are between 2 days, and you want to make sure that you count or don't count weekends or certain holidays, right? Oh, and everything is also right here, right? So we have date, date value, days 360, right? EO month showing the serial number itself, going through our ISO week number versus week number, right? Whether or not we're including that. Um, it also can, you can also change the day of the week with this one. So this allows you to be a little bit more flexible. Maybe you don't want to say Sunday's the first day of the week, right? If you want to change it to a Monday or a Tuesday, depending on when you're working, that's an extra parameter that you can include here. But honestly, just focus on the fact that it would calculate the number of weeks in the amount of weeks that you are within the year. Okay, work days. You can even calculate the hour and the minute. So if I'm dealing with times instead of dates, right? Maybe I'm saying, okay, it's 11 o'clock, right? I could say the hour of a certain date, let's say, right? Or a certain time. So our times and our times are also going to have serial numbers as well, right? So I can also format them using hour and minute, just like how I would extract a day, a month, a year. I can extract hours and minutes freely as well from there, right? So from a time difference, if I take a start time and an end time, right? Okay, we know we can just subtract them because again, all of these guys are going to have their own serial numbers, right? Let's just say I take 11 o'clock and let's say I take 12:15. All right. I'm going to subtract this one from this one, right? And we know it's an hour and 15 in between. Okay. So just like with our dates, if I were to take my formatting off, I get myself a serial number from this, right? So these are the serial numbers that are given from these time formats, right? A lot longer than a serial number here, right? Days are like whole numbers. Hours and minutes are like decimals because they are a fraction of the date. So if there is like one day, right? One day is one integer value up, right? If this originally, right, this was, I'm going to put this back to, let's say, 12 o'clock instead. So it's a little easier to see, right? I know 12 o'clock is exactly halfway through the day, right? So therefore, 12 p.m. is going to be 0.5 of a day, right? Noon. It's the midpoint of your day. So all of these serial numbers are going to be in fractions because they are a fractional part of the day. But again, whether you have dates and whether you have times, you're going to be dealing with serial numbers that allow Excel to work these magical functions and formulas. So if you needed to hard code one of these, right, you could just simply subtract, you could add, you could do all these things. The formulas, they're just doing all of that under the hood. So that way you have a better idea on how specifically these formats are working, right? And again, if I want to format these times specifically, right, just like how I could format the days, I could format it freely in the custom part too. Maybe I want to show not just a day, but I want to show like the day and the time, right? I could write that in custom, right? Or in a case like this, hour, minute, minute, maybe it's showing 3 p.m. and I want to show 300 instead. I could just do it using H for the hour, colon, and the M for the minute. So I'm free to format things however I like. Now, these formatted pretty well, so I don't have to worry too much about that, right? But let's say if I went default on time, it shows the hour, the minute, and the seconds. That's a little bit overkill. So how about I format that guy instead? Format cells. Okay. There's a lot of default times right here, right? I could show any of these. If I want, I could even show a date and a time, right? I didn't specify a date, so it just made up one. I could do any of these or go to custom and change it up, right? Maybe I want to say hour, minute, minute, and I want to say whether it's AM or PM, right? I could do that. I could have even the seconds if I wanted to, if I needed to be like super, super precise with it. I'm free to do it that way as well. So a lot of really great ways that you can essentially take control of these, right? Now it says PM instead of just saying 11 or 12 o'clock. So times work very, very similar to our dates functions. All right, let's take a break for a little bit. We'll come back in about 10 minutes, so at 12:03, and then we'll get into using logical functions. So you could take a step back for a bit. When you get back, there'll be an amplify question as well. I'll actually open that too if you want to get ahead, but otherwise, take a little break. As you guys are getting back, there's one more question on the amplify. We'll get to it in a few minutes. So, alrighty, so let's get back. We'll go over the question and then finish off with the next topic. So in the network stays international function, which argument number should you use if you want to specify that only Sunday is considered a weekend day? Okay, so if we take a look at our chart again for this, right, we could see that the first 7 of these are going to be for dual weekend days, right? So Saturday, Sunday, Sunday, Monday, etc. If we want to get a specific day, we have to use 11 through 17. So if we want Sunday only, that is going to be 11. If we wanted a different day, right, there's 12 for Monday, 13 for Tuesday, etc., etc. So for the single digits, it's going for 2 days. For the double digits, it's going for 1 day. So kind of counterintuitive there. And again, you don't have to like necessarily memorize that, oh, 1 is for Saturday, Sunday, 2 is for Sunday, Monday, but just have an idea of what these numbers specifically refer to. If they gave you a network stay formula and they gave you this table, could you fill out the network stay formula successfully? That is what matters for the specific class. Because again, you always have your references with you, just like in real life, right? They're not gonna, your boss is not gonna say, hey, I want you to do this specific question without any references at all. I mean, listen, maybe if you're like a senior Excel person that's been doing this your whole life. You could do this with your eyes closed or whatever, but like you're always going to have resources with you. You know, you can always Google something up. It's more important to know how to do something in a sense of I know I have to use this formula, or I know I have to do this, or I know how to do that. You don't necessarily need to have it memorized per se, right? You're always going to have backups in that case. So that's what's important about this class. You know, you get that hands-on experience and you learn how to apply it rather than just memorizing things plainly. Alrighty, any questions on any of the date and time stuff before we go into logical functions? Alrighty. So nothing in the chat. All right. Let's get going on the next part. So we're going to be taking a look at advanced logical functions for this, right? So we went over a little bit briefly about if statements, but now we're going to go into a couple of other logical units. So before we kind of get into the syntax itself, right, let's think about what is actually going on here, right? If I have an if statement, right? So if statement if S is going to evaluate if multiple conditions are true, right? And it's going to return a result corresponding to the first true condition. So we went over a little bit briefly about plain old if statements, right? Let's say if the value, right, hired before January 1st, 2017 is true, right? Then the salary gets multiplied by 5%, right? You get a 5% bonus if you were been here before 2017. Okay. But if S is going to go one step further than that, right? So it's going to essentially now test a second condition now. It's going to say, okay, you weren't hired before January 1st, 2017, but let's test now if you're hired before January 1st, 2027. If that one is true, then your salary only increases by 4%. Okay, maybe that's not true either. If false, then we test if they're hired on or after January 1st, 2027. This is kind of like an else condition. If this is not true, if this is not true, we go to this one by default. So otherwise, else, right? If those guys aren't true, go to this one by default, right? So if this is true, then your salary is only increased by 2%. You can also sometimes have a false condition as well, right? This is often very good to have a condition if, let's say, this was not as a date, right? If this was not a valid date, right? You like to it's important to have a condition that automatically says there's an error here, right? And Excel does this automatically, right? So if this last condition's not true, right? It's exhausted everything, then there had to be an issue, right? The date must have not been formatted correctly or something. Because think about it, you can't be hired before 2017, hired before 2027, hired after 2027. This is going to encompass all the possible dates that ever existed in the past or future. So the only way that you could have an error here is if the date was not formatted correctly in the very beginning. So now that we see what's kind of going on here, right? Let's say we wanted to actually format the way that that would look, right? We're going to essentially say the logical value first, right? We're testing to see. The test is going to be what we're testing if, let's say, the date is before January 1st, 2017, right? That's the first parameter. The second parameter is going to be the value if that's true. That's going to be salary times 5%. The next parameter is going to be the second test. That's this guy, hired before January 1st, 2027. The third parameter is the value if that test is true, right? So we're constantly alternating between the test, the value if that test is true. The next one, that value if it's true. So by default, your Excel is going to be going from the very first option all the way to the end, and it's going to try to return the very first value that it can find to be true. So if the person was hired in, let's say, 2016, right? That's before 2017. The first test is true. Therefore, it's going to return the value if that was true. But if, let's say, they were hired after that point, maybe they were hired in 2026, right? This first one would be false. So it has to go to the second value. 2026 does come before the next condition, which was 2027. Therefore, I take the value if true here. And we can continue on and on and on. You can branch this continuously on and on and on, right? I could have 3 values, 4 values, 5 values, 6 values, as many as I want. And everything is going to follow this pattern, right? It's going to continue going down. I could continue, have a 4th test, a 5th test, a 6th, on and on and on. But Excel is going to always approach it from the first to the last. So it's going to go first condition, the second condition, if that's not true, third condition, if that's not true, fourth condition, if that's not true, on and on and on. Until if it reaches the end and still nothing is true, then it will give automatically an error. So if anyone has any experience with computer science, a little bit of programming, this will probably be very, very familiar for you, right? These are very similar to coding if statements in computer science, right? We use what's called Boolean logic. It's logic between true and false statements. So the same thing is kind of happening here. Now, this is not always the most efficient way of calculating this kind of stuff, right? Sometimes we want to use what's called a switch statement instead. And what this is going to do, right, is instead of just saying test value, right, we're going to essentially evaluate the expression and compare it to a whole list of values. And it's going to return whatever corresponds to that list, right? So in the case of our flow chart here, right, let's see if I have, okay, I don't think I have one that looks like it, but that's okay because it's going to follow the same logic, right? We're going to test the expression, right? Let's say we're testing the date, right? When is this person hired? Okay. We're going to see where does this expression correspond to, right? Is the expression hired before January 1st true? Then go to the first then you go to result 1, right? So if this expression evaluates to true, go to result 1. I can add more of these as I continue on and on and on, right? I could have now a next value, right? Maybe I'm testing to see if they're hired before January 1st, 2027. I could do that instead. Maybe it evaluates to something else, right? Or maybe I'm doing a completely different idea here. I'm trying to find someone's age, right? Let's say that you want to go to an R-rated movie, right? Now, you have to be over 18 to go there. Otherwise, you have to be under 8. If you're under 18, then you have to be with a parent. So the expression could be if age is over 18, right? If age is greater than 18. Then value 1 means if this is true, right? If age is greater than 18, it evaluates to true, then you can gain entry, right? Result 1 can be true, gain entry. Otherwise, value 2, if this is false, let's say, the age is not greater than 18. Value 2 is false. Then Result 2 is also false. You cannot gain entry into the movie. So switch statements are great for listing all possible outcomes to a certain expression, right? Let's say if I'm dealing with grades, right? I could say whatever your grade is equal to, right? If your grade is equal to an A, or actually, if your grade, let's say it's converting between numerical score and alphabetical score. I take your raw grade, right? Let's say it's in the 90s range, right? Then my result, you get an A. Second value, if it's in the 80s range, you get a B. If it's in the 70s, you get a C, etc. This is great for chaining multiple conditions together, right? Without having to say, okay, if this is true, do that. If this is true, do that. I don't have to have a million if statements. All I need to say is one thing I'm testing and all the possible values that follow. So as an example of this, right, let's say I want to switch my case, right? So I'm going to be saying D2, right? So D2 is going to be the state, right? So what am I including in here? The expression, right? I'm testing for that. Okay. If the state is equal to Illinois, right? Then we output A2. A2 is Midwest. If the state is Ohio, right? Then it's Midwest. If it's Massachusetts, right? Then it's A3, Northeast. Georgia, then that's A4, South. Otherwise, right, an else case down here is just say A5, other region. So we know that we're testing the same thing every single time. We're just testing the state, right? That's what this D2 is telling me. We're testing the state here. If I know that this is Georgia, right? So Georgia is going to fall into this condition. So I know this is going to end up outputting A4 south. I can switch this D2 with any value I want. Maybe I have a whole list of these over here, right? I could say switch case and drag this formula down, and it goes for all of these guys. So I could say Georgia, Illinois, Massachusetts, etc., etc., etc. And it's going to plug in each of these states into here. This is the condition I'm testing. I'm saying, what is this equal to? Is this equal to Illinois? Is it equal to Ohio, Massachusetts, Georgia, etc.? Right? So I'm choosing from all of these switch cases over here. So this is much more efficient than writing. If it is equal to Illinois, then I'll put this. If it's equal to this, I'll put that, because I'm switching the same value every time. If I am using the same value, if I'm using the same expression, use a switch case. If I'm using different values, then my if statement is going to shine more, right? Like over here, now I'm comparing different things, right? I'm saying if this value is less than this, if this value is greater than that, let's say, right? This is testing completely different things. So I want to specify if condition 1, then do this. If condition 2, do that, because the conditions are completely different. I'm not just saying is one singular value equal to any of these possibilities. This is like a matching case, right? Matching this to this, this. Same condition, right? I'm just saying, is this equal to this? Is this equal to this? If statements can compare completely different values that are switching a lot. So it's important to make that distinction between them. Now, I'm free to nest if statements just like how I would nest functions, right? Maybe I'm saying, right, the hiring example. If you are hired here, then do this. If you're hired before here, do that. If you're hired here, do that, right? So when you nest an if statement, you're saying if this condition is true, if this condition is true, if this condition is true, and it's like following multiple gates, right? If let's say I have every single condition that I need to graduate, right? The advisor is going to ask me, Did you complete course 1? Yes. Great. Move to course 2. Did you complete course 2? Yes. Move to course 3. Did you complete course 3? No. Then you have to stop at that point. So if statements are nesting, and the only way you make it to the end is if every single thing in between is going to be true. Okay. So aside from doing our if statements, we can also compare multiple logical tests too. So again, we're dealing with Booleans, true, false values. So if I have a Boolean statement, right? If let's say condition 1 is true and condition 2 is true, or if I want to say if condition 1 is true or condition 2 is true, or if I want to say a condition is not true entirely, I can use the and, or, and not functions for these. So if, let's say, to go see a movie, you have to either be 18 and up or have a parent and guardian. I could test that by saying the or statement, right? Equal or, and I could say logical 1. Are you 18 up? Comma, do you have a parent guardian? If either of these are true, then you get an entry into the movie, right? Now, this is going to be only for or exclusively, meaning that it's going to evaluate to false if it's going to be evaluating to true. Okay, actually, wait. There's two types of or statements in computer science, so I'm just mixing it up a little bit. But this is going to be true if any of the conditions are true, meaning if one or all conditions are true. The only way it's going to be false is if all conditions are false. So and is going to be different, right? And has to be all the conditions are true, or has to be at least one condition is true. Any of my computer science friends probably understand where I got mixed up on that, but for your purposes, don't worry about it. Just think, is it going to be all conditions or at least one condition? And not is exactly what you think it is. It's the opposite. So again, I can use the and condition. I can link these guys together, right? So this is just saying if first condition, B5 is equal to manager, and if D5 is less than E2. Okay, so we want to make sure that both of these conditions are true. If they are, this function will output true. If either of these is false though, then we're going to output as false. So we can clearly see, right? If this person in row 7 is a manager, right? And D5 is less than E2, right? D5 is over here, is less than E2. So if they make this manager threshold, then they are a manager. So over here, the first one, Baccarella, is a manager, right? B5 is equal to a manager, and the salary is over 98,000. Therefore, this outputs as true. I could also use the or function here. Maybe either of these conditions need to be true. If they're a manager, but they don't make the amount of money, that would output as true if I use the or function. If I want to say that they're not a manager, for instance, I can now say if B10 is equal to manager and I wrap it in the not function, this is saying I'm going to output true if the B10 is not equal to manager. Not is going to just say the opposite of whatever is going on here. Okay. Now you can also toggle between the different functions if you want. You don't have to necessarily manually hard code them yourself. I can actually click on these guys themselves in our little function bar and insert specific functions here instead. So if you're getting kind of lost between all of the different parentheses going on, maybe you want to do it this way instead. You can click within this if or and. If you click here, you get this little pop-up, and I can essentially encode it this way instead, which is a little bit more intuitive, right? I'm actually saying this is the test I want. This is the value of true. This is the value of false. And this will actually tell me when I put in the cells if this is going to equal false or true. So I can clearly see, right? Without even coding it myself, without doing the math myself, this value is going to be false. So I know that, okay, I'm going to be having no in this position, right? This is much more informative than I put the formula in, I get no, right? Maybe I don't fully understand what's going on with the formula, right? I need to click on there and see specifically what it's referring to. And I see now, oh, this is false. That's why it's outputting no. It's giving me a little bit more details with that. Oh, I gotta hurry up. All right. So if let's say I want to combine some of my functions that I've used before with an if statement, right? I could say if, let's say, the count function is greater than whatever, right? I can nest functions. That's the way we're familiar with it, right? I could say count some sort of function that's going to return a result, and I could wrap that if in the if statement. So it's saying if the count is such and such. Or I could be much more efficient and I could use one function to do all of that. That's going to be our count if, sum if, average if. So it's combining count, sum, average with an if statement. So I'm saying count if you're counting a certain range and this is your criteria. So it's saying if the count is, let's say, greater than 10, right? Then do something, right? So it's going to do both of these functions together. It's going to calculate the count, right? And then it's going to test if that condition is met, if that count is greater than 10 or whatever it is. Sum is going to work the same way, right? Instead of counting it, maybe I sum it. Average, calculate the average, find if that condition is met. So it allows me to combine two functions that we already know into one to work much more efficiently, right? Because nesting functions is going to be kind of confusing, right? You're more prone to make an error if you're nesting multiple functions. Here it's one function. You're not going to have as many errors with that. So if I have count if, right? I'm saying count if, right? So I'm counting the range. Range is the first parameter, B2 to B8, right? And I'm seeing, right? The criteria is saying F2, right? What is F2? Is saying a count rep, right? So I'm saying if this count, right, is going to be reaching this condition here, right? Then I'm going to output the results from that. So I can access these through the more function tab if I want, or I can hard code them just like that. And I could use this with the sum. I could use this with the average, right? If I go over here, formulas, more functions. Okay, I think it's a little easier to just put them in the, actually logical it should be, I think. Or, yeah, just running out of time. But for the time being, you can essentially hard code these in. The main thing is they combine our count, sum, or average with our if. So I don't have to necessarily create a count function and wrap it in an if statement. Okay, same thing works with our average and our sum. Oh, here we go. Math and trig contains sum if, right? So if I don't really remember how to code it exactly and I need to find it, I can use the math trig book over here to do that. But we also know I could have clicked on my f of x, my function here, and I would have had a list of all my functions grouped as well. Or if you don't even want to navigate all these interfaces, you could just type it in yourself freely. Okay. Yes, we can use all of those guys. Maybe I have multiple conditions, right? So the previous ones were just count if, one condition. I know that if S is going to be multiple conditions. I could chain these just like I did with my if S, right? So what is it saying? Range 1, criteria 1. Range 2, criteria 2. Just the same format as my original if S statement. Only difference here is I'm going to be wrapping it in a count function. So that range, right? Before it was just a certain value or an expression. Now that range is going to be applied to the count function or the sum function or the average function before the if statement logic is actually going to be performed. Okay, and there's a couple of others as well. Let's say I want to find the max of multiple parameters, right? I could find the max. I could find the min. I could even detect if there's an error in any of these, right? Maybe I'm not too sure if something's going to accidentally divide by zero, right? I could use the if error function here. And that allows me to detect immediately if there was an error. Maybe it's like a hashtag value error. Maybe it's just a hashtag error. Whatever type of value it is, right? It can say if there's a value error, right? Then you can do something. So if there's an error, maybe change the formula. Maybe I have a condition to fix whatever error there is. If I know that I have an issue with my formatting per se, I can change that to make sure that I format it in a different way if there's the error. So a great way of approaching a lot of errors at once. If you know that there's a common error, using if error can allow you to address them immediately like that, right? Oh, look at that, divide by zero, exactly. Maybe you're not sure if it's going to divide by zero. If there's an error, right, then you'll say title not found per se. Or if you had a way to fix the error, you can do it that way too. But essentially, it detects the error and allows you to interpret it in a certain way. Okay, I think this is the last part. Okay, yeah. So these are going to be the financial functions. So um, if we want to calculate different financial values, we can use a variety of these functions as well. So let's say if I want to get a value of a loan or an investment that I have, right? I can plug in to the PV function, right? So present value, I put in my rate, I put the number of periods, right? The number of whether it's in months or years, etc. How many times am I paying this? Then the payment, right? How much am I putting in there, right? These are optional parameters with the brackets, but essentially it's going to find that total present value from that investment that I put in, right? But this is going to be at a present time, right? Maybe I want to find it in the future. I could use the future value, FV. This now is going to find based on whatever future value that I end up wanting to put in here, right? I can include, I can say if I wanted to have it set for a few years in the future, maybe a couple of periods in the future, etc., right? I can include a different number of periods to show how many periods in the future that I want, right? NPV, the net present value of an investment, right? We can say whether or not we want to have future payments. Maybe I have a little bit of debt that I have to pay off, right? I could use NPV in that case to essentially calculate how it would be if I also have to pay off a student loan per se, right? I have things coming in and things going out, and that's going to change my net gross in this case. Okay, we have a variety of them, financial functions, okay? When we have our, we can also use mPeriod function to say the amount of periods that we want to use, right? I could say my rate, I could plug in my PMT function and calculate that. I could calculate the rate itself as well, okay? I'm going a little bit faster with these. These are not ones that you necessarily have to memorize, but they will probably be in the labs. I'm not going to have you guys calculate these on the exam for obvious reasons. This is a computer science course, not an accounting course. So again, you just should know that they exist. If you want to be able to use them, where you can find them, right? Financial functions, we can do that in the financial tab of our functions tab. Otherwise, we're free to kind of use these to find a variety of those functions that we need for accounting or economics, etc. If I have loan information, right, I can convert this into a table that shows my principal and my interest values, right? So if I have all of these values, right, I have my loan, my APR, my years, payments per year, right? I can simply plug these into a table, right? Have my initial values and continue going down. We know how to apply a formula to multiple different values, right? If I wanted to, I could use my what if function that we learned yesterday to calculate how it would be if I changed maybe my APR, maybe the number of years, payment per years, etc., across different periods. And I can graph my principal and my interest amounts over that time period. Okay, and to do that, right, I can use the IPMT function for that, right? The key here is I for identical. So this is going to be for identical periodic payments, right? Maybe I am not using identical payments every single time, right? If I need to change that, right, I can always put that into my function. I could calculate my PPMT instead, right? And this allows me to calculate which types of loans that I'm using, right? So I could calculate my interest through these. I wouldn't worry too much about this. And that is the end. Let's do the last couple of amplify questions, and that way you guys can get out on time on that. Let me just open that up. Okay. So I know I kind of rushed through the last part, but the keys here, right? What did we cover today? We went over date and time functions, right? Knowing the basics of those, what each one does, right? The difference between them, right? If you're asked to, let's say, calculate the number of days in between, excluding weekends, what function do you want to use for that? Things like that. We went over logical functions. So using if statements, switch cases, using ands and ors, things like that. We know we can calculate one condition, or we can chain multiple conditions by using if s instead of just if. The variety of financial functions as well. Um, Again, financial functions, this is more of a computer science class, not necessarily financial, just knowing that they exist. I'm not going to ask you to calculate someone's mortgage loans. Save that for your accounting or economics class. But just knowing that they exist, right? Knowing that I can go into my financial functions and I can see them all here. There's a lot of different functions here, right? But if I need like IPMT, could do that. If I need to find any kinds of functions that are dealing with accounting, PMTs, PPMTs, etc., I could find different rates. I could find all of these in my financial functions itself. Key is know that they exist, know that you can use them, right? Know that essentially all you're doing are just plugging in those specific values. Okay. And again, you're going to get more practice with this in the lab itself for the purposes of the exam, since, I know it is coming up and everything. It'll be simpler types of questions, right? Like, if you want to do X, what function should you use? Things like that. And we'll be sure to go over more questions about that as well, especially with lab. In the meantime, I'll give you guys a minute to finish up the questions, go over them, then we can head out for the day. But if you have any questions in the meantime, feel free to ask me, either in the chat, in person, whatever. But I'll give you guys a minute to finish that up, and then we can conclude. Yeah, of course. Have a good day. Okay. Okay, I'm glad that things are making sense. I know we cover a lot of information and stuff, and unfortunately, my computer science side kind of took over at the end. I spent more time on the stuff that related to computer science than the stuff relating to accounting and everything. So apologies for that. But as a result, the exam will focus more on that. Okay, anyway, let's go through a couple of the questions really quick, and that way you guys can head out for the day. Alrighty. Which function should be used to determine the strength between two variables, right? We want to essentially say we want to show, actually, I think hang on one second. I just want to make sure I didn't mix this question up with something else. Oh, I'm really sorry. This question got mixed up too. Um, yeah, this is actually not the right question for this specific problem. The actual original question was supposed to be which logical function evaluates an expression, compares it to a list of values, and returns a result corresponding to the first matching value it finds. That was supposed to be the actual question that it was supposed to be for. I think I accidentally mixed this up. I was working on the chapter 8 one at the same time, and I accidentally put the wrong question in here, but the right answers for that. I'll put the actual question in the chat that I was supposed to be answering with this, right?
Professor, we don't get graded on these, right? Like besides
Absolutely
it?
not. Yeah,
Okay.
don't worry. It's just participation based.
Okay.
Yeah, I was also supposed to reflect kind of similar questions that you would get for like the exams too, so don't even worry about that. It's just more important that you understand this. But yeah, so this question was supposed to be which logical function evaluates an expression, compares it to a list of values, and returns a result corresponding to the first matching value it finds. Okay, so this is going to be based on our switch case, right? The key here is it's going to be a list of values, right? So if I have a list of values, this is going to be a switch case. If I was just going through a variety of statements, right? Statement value pairs, that would be our if statement from that. Uh, if NA is going to be if not, and or is going to just compare if out of a bunch of conditions that at least one is true. Sorry about that, but yeah, so this one key here, a list of values we're comparing an expression to, that's always going to be our switch case in that case. So sorry, I had the wrong question here. So just disregard this. This is actually for Monday's lesson. Um, yeah, sorry about that. I think the other ones should be okay with that. And yeah, aside from me having copy paste errors, because of course, did not have enough coffee, it seems. Sorry about that. All right, so when evaluating multiple logical tests, which function displays true only if all the conditions are going to be true? This is going to be our and condition, right? So and is saying if this condition and this condition and that condition are all true, then output true. If it was only some, right? If it was only at least one, then it would be or in that case. Okay, if you need to count the number of cells in a range that meet multiple specific criteria, for example, finding employees who are both managers and have a salary over 80,000, which function should you use in this case, right? So in this case, right, we want to say if someone's a manager and has a salary over 80,000, right? So what I can use here is because I'm dealing with a string of I'm dealing with like a text-based answer and a numerical answer, right? I want to use the count ifs function, right? So this is going to test if this condition is true and if this is condition is true. Okay. Now that's what the if part is doing, right? If this part is true and this part is true. If s because multiple conditions, then it's going to count how many true values there are going to be. If this is true, check. If this is true, check. I want to count both of those values, right? So we're combining two different values rather than hard coding this example there. Okay, oops, skip that one. Okay. And then the last question over here, right? When building a loan amortization table to break down your identical periodic payments, what is the exact difference between the IPMT function and PPMT functions? Okay, I know we kind of went a little bit quicker on this specific one, so let me go back to the slides itself on this, right? So IPMT versus PPMT. So IPMT is going to calculate the periodic interest for a specific payment period, right? Principal payment itself, right? So we could see we got the periodic interest for a specified payment period, and this is going to be calculating the principal payment itself for that. Okay, again, don't worry too much about the specific financial formulas. I'm not going to say calculate the periodic interest. That would be crazy. But on some of the lab assignments, you might have to use this function, right? You're going to get a little bit of practice with using a variety of them. And again, on the exam, right? I'm not going to say like specify like this like very small details between multiple functions. It's going to be a lot more straightforward, more like the previous questions. Or maybe I might ask like, yeah, which of these functions can be used for interest? And I might have like IPMT and then some others that are like very unrelated to it. So don't worry too much about the specific details of it. The exam will have more fair questions. I'm not going to have you memorize every single financial formula here. The most important thing is that they exist, right? And you're going to have your notes with you, right? If you know where they are in your notes, right, you can match where it is. So shouldn't be too bad with that. With that being said, sorry about going over a little bit. If you have questions, please let me know. I'll be on for a little bit longer. Otherwise, you're free to go. You were free to go before, but I hope you guys have a wonderful day. And again, if you have questions, let me know. And during lab, you'll have more time to also go over it. Yeah, of course. Have a good day as well. It's really warm out today. Hopefully you guys could enjoy the weather, go outside a little bit. Yeah, of course. Have a good weekend too. I think the weather's going to be nice on the weekend. Good beach weather.